let's learn how to divide complex numbers. So to divide complex numbers, we're going to have to use something to help us out, and that is the conjugate of the denominator. So to simplify the quotient a plus bi divided by c plus di, multiply the numerator and denominator by the complex conjugate of the denominator. All right, so we're going to, so if our numerator, or excuse me, if our denominator is c plus di, the conjugate would be c minus di. Now this over here just shows you what's going to happen when you multiply, but rather than trying to plug things into a formula and look where things go, let's just multiply, all right? If you just do with what, use what you know, right, I think it'll make more sense for you. Let's do a little practice problem that's not in your notes, and then we'll do two that are in your notes. All right, so let's take 3 plus 6i, I mean, that's fine, and divided by 4 minus 5i. All right, that's fine. All right, so actually let's make it 4 plus 5i. All right, so now we're going to multiply by the conjugate of the denominator. So we're going to multiply by 4 minus 5i. Right? Because if our denominator is 4 plus 5i, the conjugate would be the same thing, but the opposite sign. Right? Right, so same terms, opposite operation. Between terms. So plus goes to subtraction, subtraction goes to plus. So here we have 3 plus 6i over 4 plus 5i times 4 minus 5i over 4 minus 5i. And because you're multiplying by the same thing in the numerator and denominator, it's just a form of 1. So let's go ahead and multiply by distribution. Actually, let's multiply by FOILing, right, because it's kind of set up. So we'll multiply the first terms. So 3 times the negative 5i. Then we'll multiply the outer terms. So that would be the 3, oh, excuse me, I grabbed the wrong term. My shadow was blocking. The first terms, 3 times 4, the first terms in those two binomials, plus the outer terms, which would be 3 times negative 5i, plus the inner terms, which would be 6i times 4, plus the last terms, which would be 6i times negative 5i. In the denominator, we'll have the first terms, 4 times 4, plus the outer terms, so that's going to be 4 times negative 5i, plus the inner terms, so that will be 5i times 4, plus the last terms, which would be 5i times negative 5i. All right, so now let's multiply. All right, so I guess I'll just go right here underneath. All right, so 3 times 4, that's going to give us 12, plus, and actually I may as well just change that to a minus sign, right, because that's a negative there, we had negative 5i. So minus 15i, right, 3 times 5, plus 4 times 6, 24i. And then we have a negative sign, so minus. And then 5 times 6 would be 30. And then I times I would be I squared. And then in the denominator, we have 4 times 4, so 16. And then we have negative 20i plus 20i. And then we have minus 5 times 5 would be 25. I times I would be I squared. So let's simplify that. All right, so let's first of all replace the I squared with negative 1, right? Because remember, I squared equals negative 1. So we have 12, and we can combine those, all right? So plus negative 15 plus 24i, right? We're going to combine our I terms. And then minus 30 times negative 1 divided by 16. Notice the negative 20 and the I and the positive 20i will cancel each other out. That will always happen when you multiply by a conjugate. Your middle terms drop out. You only end up with the first term squared and the last term squared. And then we have negative 25 times negative 1. So notice, so we'll stop and we'll look at all the individual parts of that formula just to show you that we are doing the exact same thing. Let's simplify and combine our terms. So we have 12. That's going to be a plus 9i. Plus 9i. And then plus 30. Divided by 16 minus a negative, that's going to be plus 25. So we can combine the two numbers there. That's going to give us 42 plus 9i divided by 41. And we can split that up into two fractions because we have a single number in the denominator. That's how we're able to divide. I'll just move that over so that I can. So let's just split that fraction up. So now we have equals 42 over 41 plus 9i over 41. And there you go. That's all there is to that. All right, a little multiplication, a little addition, all right, and then simplifying at the end. All right, now let's take a look at our formula here, and you can see that we have all the parts covered. All right, so the A times C part. All right, so for ours, A and C, that's the 3 and the 4. We've got that right here. Oh boy, that pink is bright, isn't it? I'll just do it like that so you can maybe see through it. And then the B times D part. All right, so that would be the 6i times the 5i. That's over here. And then the B times C part. All right, that would be the 6 times the 4. That's over here. And then we have the A times D. All right, so that would be the 3 times the 5i, and that's over here. And in the denominator, notice that we get, I ran out of colors, C squared plus D squared. All right, and notice for our equation, so C is 4 and D is 5. 4 squared is 16. 5 squared is 25. We have, I'll just repeat a color. We have this right over here. All right, so we have all of the products, but rather than trying to memorize the formula, right, we just multiplied, all right, and everything works out, right, because that B times times D, we don't have to worry about that I, right, because that we already get the I squared, and we replace that with a negative 1, right? When we replace, we have a subtraction sign. When we replace the I squared with a negative 1, automatically we're going to have a plus there. So rather than trying to memorize things, where's the plus, where's the minus, what things are multiplied, just multiply by the conjugate, right? And just use FOIL, things you know. And then when you combine your like terms, it'll all work out. When you get to the end and you have just a single term, like we have right here, all right, just divide both of those terms in the numerator by the denominator, and you're all done. And that's how we divide complex numbers. Let's do a couple more. All right, so let's look at the first one. All right, so we're going to, when it tells us to divide complex numbers, we know we're going to multiply numerator and denominator by the conjugate. So we have 3 plus 5i over 1 minus 2i times the conjugate of 1 minus 2i would be 1 plus 2i. And so we're going to have 3 times 1 in the numerator plus the first terms, the outer terms will be 3 times 2i. The inner terms will be 5i times 1. And then the last terms will be 5i times 2i. All right, and then in the denominator, we have 1 times 1. And then the outer terms will be plus 1 times 2i. The inner terms will be negative 2i times 1. And the last terms will be negative 2i times 2i. Let's multiply. So we've got 3 plus 3 times 2i would be 6i. 5i times 1 is 5i. 5i times 2i would be 10i squared over, all right, we got 1 times 1 plus 1 times 2i is 2i. Negative 2i times 1 is negative 2i. Look, those middle terms are going to drop out again. Right? And that'll always happen if you, it doesn't even have to be complex numbers. Anytime you multiply by the conjugate, right, you're going to end up with a difference of squares. The middle terms will drop out. And then we have negative 2i times negative 2i. That's going to be negative 4i squared. All right, so let's replace that. I guess I'll go over here. We'll replace the I squareds with negative 1s. So we have 3 plus, I guess we can combine those. So 6 plus 5 times I. And then plus 10 times negative 1 divided by, we've got, well, we don't have to write the 2i minus 2i. 1 minus 4 times negative 1. Right? And so that's going to be 3, this of course is just negative 10, right? So 3 minus 10 is going to be a negative 7. And 6 plus 5i, that's going to be 11i. And then what's going to be 1 plus 4? That's going to be 5. I hope you, if that's okay, if I just combine a couple steps together, like multiplying by a negative 1 and adding them together. All right, so now we're almost done. Now we're going to divide their terms by 5. All right, so we have negative 7 fifths plus 11i fifths. And that's all there is to it. All right, so notice that in the denominator you end up with the first one squared, and it ends up being plus, right? Because it's a difference of squares is always going to be, there's always going to be a subtraction sign somewhere. That second term will be negative, but when you plug in the negative 1, that makes it positive. All right? So what happens if you don't have 2 terms? You only have 1 term. You're going to multiply by the opposite. So if you only have or if there is only an I plus whatever its coefficient is, multiply by the opposite. All right, so usually put a coefficient, right, b, right? So bi becomes negative bi. All right, so multiply by negative bi. Actually, I'll put, instead of the I here, I'll put bi. Right, because it could have a coefficient. Multiply by the opposite, negative bi. Whatever sign. If it was negative, you'd multiply by a positive. All right, so we're going to have 7 plus 3i over 4i times negative 4i over negative 4i. All right, and think about why we want it to be the opposite. All right, if we have a negative there and we replace, we're going to have an I squared because we're multiplying I times I. If we also have a subtraction sign, when we replace the I squared with a negative 1, we're going to have a positive number. And we want the denominator to be positive. That's why it's the opposite. All right, so let's just multiply. It's going to be 7 times negative 4i plus 3i times negative 4i, all divided by 4i times negative 4i. All right, let's simplify that. So that's going to be negative 28i plus 12, minus 12. Right, 3 times negative 4, and then I squared, divided by negative 16, 4 times negative 4, I times I squared. All right, let's simplify that. So we've got, and let's switch the order at the same time, I guess. Actually, we'll just simplify, and then we'll switch the order. Negative 28i minus 12 times negative 1 divided by negative 16 times negative 1. So we're going to end up moving this over so that we have a little bit more space. So we're going to end up with a positive 12. Let's put that first, because right, we put the number first, the real, then the complex part, then the imaginary part. Minus 28i divided by 16. All right, and so now we'll reduce that. So we have 12 sixteenths minus 28i sixteenths, and that does reduce to 3/4 minus, right, they're both divisible by 4. 28 and 16 are divisible by 4. That would be minus 7i over 4. And there we go. We just reduced. And there is our answer. So here's the second one, what to do if you just have a single I. And the first one, what to do if you have a binomial. And that's the only situations we have. A single I, there we go, or we have a binomial. I hope you can follow that. If not, I can split that. And I think that's where I'm going to stop. I had originally rewrote it, but we were able to squeeze it in. All right, so thanks for watching. Bye for now.